The process of regulating cholesterol is very complex and multifaceted, with multiple layers of control. The current nutrition science, and especially in the field of lipidology, the study of lipids, is somewhat flawed, as a lot of healthcare providers don't have a very good understanding of it. As a result, they seem to only reiterate the conventional wisdom when it comes to assessing cholesterol in a metabolic blood panel. The issue stems from the fact that cholesterol, traditionally divided into the two classes of lipoprotein, high-density lipoprotein, HDL, and low-density lipoprotein, LDL, is measured in a very old-fashioned way. HDL has arbitrarily been given the nickname of good cholesterol, while LDL has been associated with bad cholesterol. Most HDL is good, but with LDL it's a very different story. There are two major types of LDL. The first one, LDL-A, looks like a big fluffy cotton ball under a microscope and does just about as much damage. Metaphorically speaking, LDL-A is sort of like a tennis ball. The second type, LDL-B, however, is like a golf ball. These smaller size particles are little, small, angry, oxidized molecules that can really cause damage. If you throw a tennis ball at the net, it just bounces off the webbing, but throw a golf ball at a tennis net and it can rip the webbing apart. A similar effect happens in the walls of blood vessels. The large, fluffy tennis ball-like LDL particles bounce off the walls. The small, dense golf ball-like LDL particles break through the blood vessel walls, and this is how damage to the blood vessels start to occur. Statistically speaking, if you have increasing levels of large buoyant LDL, the risk of heart disease doesn't change. Whereas if you have increasing levels of small dense LDL, the risk of heart disease increases threefold. So it's not LDL that causes heart disease, it's small dense LDL or LDLB. The difference between LDL-A and LDL-B is not seen in the standard cholesterol test, because it just lumps all the subfractions together under the general names of HDL or LDL. It is not good enough anymore because it doesn't tell us what we want to know. In other words, how much of the LDL is the big cotton ball molecule LDL-A and how much is the harmful kind LDL-B.